Hello and welcome back, and in this video we're going to cover section 2.1 functions and the difference quotient. Now the difference quotient is an evaluation where we do f of x or f of 3, but it's written in terms of a couple different evaluations that we then evaluate a quotient. So there's going to be a difference of two evaluations and a quotient. Now this example of a difference quotient uses a value for a like 3. So you might see f of 3 plus h minus f of 3 over h. So this is a difference quotient where the value is given. This one, the second difference quotient here, is when we evaluate a general formula for x. So that we just evaluate x plus h minus f of x. Now we're going to do these two examples, or these two difference quotients, with this one example here. So we're going to spend a little bit of time going through how to write a difference quotient. So in the difference quotient we're going to have three parts. Okay, so in this example I'm going to use f of 3 plus h minus f of 3 over h. So this is a specific difference quotient for the value of 3 for a. So when we do this, we're going to evaluate this f of x for these two values. So we're going to take the numerator part and we're going to break it up into two different evaluation pieces. So we're going to do f of 3 plus h, and we're going to do f of 3. So in each of these we're going to plug in the values in the parentheses to the function and evaluate or simplify. So in the first part here we're going to have 3 plus h squared plus 5 times 3 plus h minus 1. Now f of 3 is going to be a little bit more complicated, or a little bit easier because we just plug 3 in. So let me erase this because I'm going to need to simplify the f of 3 plus h a little bit, and we'll move that down to a little bit less. We'll need a couple more spaces for f of 3 plus h to evaluate. So here, when we're evaluating this, we're going to need to do FOIL on the 3 plus h squared. Oops. So we're going to need to write the 3 plus h twice. And we're going to evaluate 5 times 3 plus h, and then minus 1. So here we're going to do FOIL. We should get 9 for the first. Outside is 3h, inside is 3h. So we're going to get 6h there, and then we have the last two, which is h squared. So and then this next term we're going to have 15 using our distributive property plus 5h minus 1. Now that's going to simplify into, let's see, we're going to add 9 and 15 and get 24. Subtract 1 and get 23. We'll have 6h and 5h, so that's 11h and an h squared. So that's what my evaluation for f of 3 plus h. Now we're going to evaluate f of 3 in there, so we're going to put in 3 squared plus 5 times 3 minus 1. So we get 9 plus 15 minus 1. So we get 24 minus 1 is 23. So we've evaluated both of these for f of 3 plus h, which is this thing right here. And we've evaluated f of 3, and we've gotten this value. Now we just need to plug those into this actual difference quotient to evaluate the difference quotient. So now we can evaluate the difference quotient. We now know what f of 3 plus h is. It's this value in red here. So we can type in, or we write in 23 plus 11h plus h squared, and then we know what f of 3 is. That's 23, so we're going to go minus 23 for the minus f of 3, and then we're going to put that all over h. So our value here, these two will drop out, and we'll get 11h minus 8 or plus h squared all over h, and we're going to reduce that by dividing both pieces by h, and we'll get 11 plus h, and that's evaluated for this term. So this difference quotient, f of 3 plus h minus f of 3 over h, is going to reduce to 11 plus h. Now let's also run this evaluation on f of x plus h minus f of x. This is the general difference quotient. Let's do that on this same example. So on this example, we're going to do f of x plus h minus f of x all over h. Now this one, we're going to still evaluate two things, but on the second thing, we've already evaluated f of x. F of x is this function up here. So that's already given to us. I know what f of x is. F of x is going to be x squared plus 5x minus 1. We have to evaluate this piece here of the difference quotient, which is f of x plus h. And so we need to plug in the x plus h, just like we plugged in 3 plus h into the function x plus h squared plus 5 times x plus h minus 1. And we're going to evaluate this in the same way. We're going to do our FOIL on this first term. And we're going to evaluate the rest of this distributive property. We're going to get x squared. We have outside is xh, inside is xh, so we're going to get 2xh. And we're going to have an h squared. We're going to then distribute this 5, 5x plus 5h minus 1. So this is going to reduce a little bit. Actually, there isn't anything we can combine to that. So we're going to have, that's going to be our first term of our difference quotient. So our difference quotient, we got to do the f of x plus h. So the f of x plus h is this whole thing. That's f of x plus h. We also would have to do f of x. This is f of x plus h right here. And then we have to do the f of x, which we knew what that was. That was the formula right here. So we're going to evaluate this difference quotient by rewriting it, putting in the values we know for f of x plus h, putting in the values we know for f of x. So it's going to be x squared plus 2xh plus h squared plus 5x plus 5h minus 1, and then we're going to subtract all of this f of x. So that's x squared plus 5x minus 1. And that's all over h. So this is the difference quotient evaluated for this function that we're doing up here, this x squared plus 5x minus 1. And this is the general difference quotient formula for x. So when we do this, we then have, we're going to change all the signs. So the first terms stay the same. But here we change the sign, so that's going to be minus x squared minus 5x plus 1. So we do the distributive property there and change all the signs. What's going to happen then is some of the terms will reduce. This x squared here will reduce with this x squared. The h squared, no, 5x here. 5x is going to be gone with this 5x, and the positive 1 and the negative 1 is going to be gone, so we can reduce those. So we're going to end up with a little bit simpler expression. I have 2xh plus h squared plus 5h over h. Now we want to reduce all of those by writing them separately, so we have 2xh over h plus h squared over h plus 5h over h, because they're all reduced by h or divided by h. So we end up with 2x plus h plus 5. So this is the evaluation of the difference quotient for the function x squared plus 5x minus 1. Now when you do the difference quotients correctly, you're going to be able to reduce the h in every term. So if you can't find the values where all the h's reduce out, then you might have done something wrong. If that happens, you want to go back and check your work again. So if you can't divide by h every time and every term and reduce, you might have done some math wrong, so go back and check your work.